Hey everyone again. One real quick thing that I forgot to go over is the runtime for this problem. My bad. I ended the recording a little bit too early. Okay, so the runtime for this problem, as we know, it's supposed to be O of n cubed, right? And so let's just kind of prove it a little bit down here. Let's just say, let me pull this entire algorithm down. So this is our algorithm. And basically, let's just go over the runtime. Okay, so we know that we're doing for each letter in grid, right? And so this immediately says we're doing basically for, or we'll say for n squared characters. I'll just basically translate this code up here, the pseudocode up here, into a little bit of runtime code, I guess. So for n squared characters, we know that what we're doing is we're checking 8 different directions, right? So check 8 directions. So actually, we can even model it as for each of 8 directions. So for each of the 8 directions, what we want to do is we basically want to get that string, get string s, and then run lps on s. That's the main work that's being done, right? And then also, remove from try. So these are basically the main runtime things that are happening, right? So here we're doing n squared work. Here we're doing 8, or let's say n squared iterations, 8 iterations. And so now we need to figure out how much work all of this takes, right? To figure out our total runtime. So getting the string s is a pretty straightforward operation. We basically just go back, we track back through the grid and get those letters, right? And so that should take, in the worst case, it should take n time, right? The reason being, we know that our grid is n by n, right? So the maximum length of a string of characters in one direction is n, right? We can start here, and this is going to be n characters, right? And so basically what that means is that the most characters we can have in our string s is going to be, this is basically going to be an O of n operation, O of n. LPS of s is actually very similar, right? Because now once we get the string s, we know that it's at most of length n. And checking for a string in our try is also like a constant time operation with respect to the length of the string. And so if the length of the string is n, that means that this is also an O of n operation, right? Because basically we need to trace through the try letter by letter, checking for the longest prefix. And so in the worst case, the longest prefix is the entire word itself, which means that we would do n separate comparisons to figure out LPS of s. So what that means that this is also an O of n operation. And then finally, removing from try is the exact same as LPS of try, because basically we're just tracing through our try again and removing letters this time instead of just searching for them. So these are all O of n time operations, meaning that this entire block is an O of n, right? So now we see, okay, we have n squared iterations on the outside times 8 iterations inside that times n work total. So we technically have 8 n cubed, which simplifies to O of n cubed because we don't care about constants. And yeah, that's the total runtime. So as you can see, it follows our runtime constraint. And that's kind of what I did right here in the beginning, is that we can do n work per letter, which is what we ended up doing in the worst case. Yeah, okay, this time for real. Goodbye. See you guys next time.